Hey everyone, in this video tutorial I'll be taking you through Module 5 of Wireless Sensor Networks that which discusses about challenges faced in time synchronization by a wireless sensor node. Time synchronization protocols have to address various design challenges and there are a lot of factors that which are affecting these time synchronization and under challenges we have these many challenges listed. The very first being low cost clocks, resource constraint, wireless communication, high density, and node failure. And in order to remember this, just remember the abbreviation LRWAN. Only thing is A will be replaced with H, where L stands for low cost clocks, R stands for resource constraints, W stands for wireless communication, H for high density, and N for node failures. And addition to this, synchronization techniques have to also address mapping between sensor network time with internet time, that is UTC. Now let's take up the very first challenge, that which is low cost clocks. So here low end crystals are used for manufacturing local clocks, which in turn results in frequent clock drift and clock jitter throughout the lifetime of the node. And here we can mathematically model time represented by the clock of a node I as tau I of t, where tau I is in fact equal to alpha I plus theta alpha I into t plus theta I, where alpha I is clock drift and theta I is clock offset. So ideally speaking, this alpha should be equal to 1 and theta should be equal to 0. So that is offset should be equal to 0 and drift should be equal to 1 for a perfect clock. And here we can also represent the same time tau I of t in terms of its neighbor node, that is node j. Only thing is here this drift will be replaced with one more subscript j and will also include the time of node j plus theta ij, that which is the clock offset. Synchronization protocols aim to correct relative differences between these two clocks. They won't actually aim at syncing the network time to the internet time, but they'll try to bring down the differences between the relative clocks. Periodic, and in order to do so, or for the synchronization protocol to work, periodic message exchanges should happen between the nodes, or something called as relative clock drift estimation should be done between the nodes. So that's about low cost clocks. Then we have this resource constraint. Wireless sensor nodes are constrained in terms of energy, processing and memory because of limited resources. Traditional synchronization methods cannot be used for wireless sensor networks since transmission and reception of packets constitute major energy consumption in sensor nodes. So traditional way of doing the synchronization, timing synchronization won't work in with the wireless sensor network. Then we have this wireless communication. As we all know that these nodes communicate wirelessly, synchronization requires nodes to communicate with each other to exchange clock information through which local clocks can be synchronized. Synchronization is trivial in wired network such as internet, but whereas in wireless sensor network, wireless communication between nodes is happening. This creates additional challenges for synchronization. Wireless channel errors results in some of the synchronization messages being lost, and when these synchronization messages are being lost, so this will lead to the generation of unsynchronized nodes, and these unsynchronized nodes will in turn force the other nodes to adapt their clocks to their neighbors, and consequently the entire network will be partitioned into two or more different zones. So wireless channel introduces a symmetric delay in each direction, that is from sink to the node and node to the sink. So this is all happening because of this challenge, that is wireless communication. Next we have high density. We all know that wireless sensor networks are not deployed in one digit number or two digit number, but they are deployed in thousands of numbers. So thereby wireless sensor networks are characterized by very high density in network. As a result, solution based on pairwise synchronization is not suitable. So pairwise, instead of pairwise, they can make use of, or they can exploit the broadcast nature of wireless channel, such as reference broadcast synchronization is suitable technique for achieving this. Instead of going for pairwise synchronization, they can go for broadcast synchronization. And ultimately, we have the last challenge, that is the node failure. So because these low cost, these wireless sensor nodes are made by low quality hardware and limited energy sources. This results in frequent node failures. So thereby we cannot rely on a single node as master clock in this situation. So thereby we need to have distributed and robust solution that are not affected by node failures. Such kind of system is required, that is distributed, so that it can keep on changing the master clock node as well as a robust solution. So these are all the challenges that which time synchronization has to address. And in our next tutorial, we'll go through timing synchronization protocol for sensor network, abbreviated as TPSN, and how exactly it works. We'll be going through that. Thanks for watching.